probably because the RPMs are dropping and the pressure is going up to 110, which is good because we're looking for 107, so that looks about right, but it should not fall off. Clearly there's a problem. So like I said, my suspicion is the air system. What you're looking at here is the fuel pressure with the key in but not started, and that is exactly what we want to see. I think this gauge reads a little bit high, but it should be 27 psi, so we're a little around 30 or so, and I think this gauge, that's within the accuracy of this gauge, but it's very steady and repeatable. So I believe that the fuel pump and the fuel pressure regulator are probably okay. But if you know how the air injection system works with the fuel system, there could be a problem with the air regulator, and that would throw off the fuel pressure. All right, so I'm suspecting the air system. Here is your air regulator. Here's your fuel regulator, and they're tied to each other, but the air regulator should maintain the high pressure air in the fuel rail all along here at 80 psi. And if you know the DI system, it has the air pump down here. All it does is pump out air into this high pressure supply hose, and the regulator will relieve pressure to maintain the pressure at 80 psi, and that should be a pretty steady 80 psi as long as it's running. So since our pressure is our fuel pressure is going up to the correct set point but then falling off, if the air pressure falls off, so will the fuel pressure, because they're tied together. If this air regulator is not closing completely, I think that could be the case. So we want to check air pressure in the system while it's running, and the way to do that is to tee into this line. And I know guys talk about cutting that line. That's a pretty expensive line. We're not going to do that. So we're going to make up a fitting to tie in right here. And I'm going to show you that and show you how easy it is to check that air pressure. So here is the fitting that I've made up. This is going to be installed between the high pressure air hose and the fuel rail. And on this hose barb, we're going to attach the pressure gauge. So we'll have an inline pressure gauge to read the air pressure. This will go in here. And you can see this fitting just replicates the end of the air hose. So we should see steady pressure when the engine is running of 80 psi. Okay, so we have our fitting installed with the pressure gauge. You can see the whole setup right here. And what we have is just a T, basically, hooked up to a pressure gauge. So now we're going to run the ski, and we'll see what we get. Okay, so there you have it. The air pressure is going up to the set point, which is 80, and the regulator valve is lifting off, which it should, but then it's not closing apparently. And there could be some debris in there, or the spring could be broke or whatever. So we're going to have to tear into that. But the fuel pressure is just going to follow along with that air pressure. So I think if we get the air regulated at a steady 80 psi, I think the fuel system is fine. All right, so we'll tear into that next. Okay, so we have the air regulator and fuel regulator out. And this is the fuel regulator. And as you can see, there's a bunch of debris around the O-ring, which could be causing some bypass of the O-ring and causing a problem. It could mean there's more debris. It could mean that we have clogged injectors too, if there was debris down into the injectors. There's also some pretty cruddy fuel in there, so we could have some contaminated gas. This is a rebuild of the ski that's been sitting for quite a long time, and I didn't get all the gas out of the tank. Might have to do that. This is the air regulator. It doesn't look too dirty, but it could just be not working. Okay, so we've taken the fuel rail apart and the injectors and blown everything out and looked for more debris. Seems to be pretty clean now. So we're going to put it back together and try it. Okay, so after all those fixes, all the cleaning and changing many of the O-rings, it no longer is doing the surge. I've got a nice steady idle. I have soap bubble tested everything, including my made up fitting, but you know, everywhere there's air pressure, you just, while it's running, soap bubble test everything. Like I said, these port plugs on the end, around the regulators, everywhere. If you have a fuel leak, you're going to see it or smell it, but in the air side, once you think you have everything sealed up tight, soap bubble check everything, which everything is tight now. But what I'm getting is, at idle, I'm getting a low pressure. I'll show you that. I'm getting about 40 psi. I'll show you that in a minute. So I think it should be 80, even at idle. Now the pressure will go up when I rev it, but it still runs a little bit rough. And so at this point, maybe I have it isolated down to the air pressure regulator. And at this point, that's the only thing I could think of needing fixed. So we're gonna start it up here. Okay, so since we have low pressure but steady, I think we've probably fixed some leaks along the way. And now I'm still debating on the replacing the air regulator. There is another set of tests I want to do, and I just thought I'd throw this in because this is a good way to do a soap bubble test. This fitting can also be hooked up to air pressure, and that's going to pressurize the air system it'll check the reed valve in the dome of the compressor, which should only let air out, not back in. So that should be sealing. We'll be able to soap bubble test everything, which, like I said, I've already done that with the engine running, but this is another good way you could do that. And we could soap bubble test there's O-rings between the air injector and the head, the bottom of the fuel rail, all this stuff. Now, I also don't hear anything hissing, and I've got this hooked up to my air supply, and I'm going to show you. Right now we're holding steady. I'm going to start out at about 40 psi. That's where we're at, and I'm going to just slowly crank it up because I know at 40 things were okay, and at 80 the air regulator should lift off. So now I'm approaching 80. Now when I hit 80, that air pressure regulator on the ski should lift off, and it should not go above 80. All right, so I don't know if you can hear that, but we are relieving pressure. Okay, so the air regulator is now releasing pressure, and you can hear hissing from the rear end of the machine, and I'll show you where that air comes out. But in behind the injection rail, there is your exhaust hose for that regulator. That is always the orange or red line, and that's red because that's air pressure, and I replaced that on this ski. I think it's 100 psi pressure rated, and for those who aren't familiar with it, that exhaust goes out an air quieter that's down near your exhaust pipe. But that's what this is right here. And that actually mixes with water, and the purpose is to quiet that hiss so you never really hear that when you're running. All right, so this is turning out to be one of the more difficult jet skis I've had to troubleshoot and get running. I think we've had multiple problems, little leaks here and there in the air system, but as I showed you, I think everything is sealed up good and tight. We've soap bubble checked everything. The fuel pressure is following the air pressure like it should, but the air pressure is still low when it's running. But before we tear into the pump or try to troubleshoot that further, I want to see if this thing will just run like it should. And to do that, we're going to supply this thing with air, 80 psi, compressed air from the compressor. The engine shouldn't care where the air comes from as long as it's got a good constant supply. So I made another fitting up. As you can see here, this is going to go into our test fitting, and then we're just going to connect the hose to the compressor, and we're going to run it just like that. And we'll be able to monitor pressure in the air system. Should be a steady 80, and hopefully it runs smooth, and at least that'll tell me if the computer or fuel injectors, etc., are working properly. Alright, so with compressed air at 80 psi into our fitting, here. We're running smooth, steady RPM. We should be idling at around 1450 RPM. That's perfect. Fuel pressure is perfect. Should be 107, so we're reading high on this gauge, but it's steady, and that's what we want. So so we're going to check the air compressor, and I just have a hose hooked to our pressure gauge, although you should have a relief valve in this hose because basically we're deadheading the compressor. So the manual says you should have at least 90 psi. I think that we're not really going to get pressure because I think the problem is the pump, and this hose will blow off here anyway. So I'm going to do a quick check of this. Yeah, and you can see I've got no pressure at all out of the pump. And it's a little hard to believe because when things were running, I was getting upwards of around 40 psi, maybe. When it's cranking faster, I get some pressure, but I believe we've isolated the problem to the air compressor, so we're going to be tearing into that next. All right, so the problem has to be the pump, but I don't think it's the piston or rings themselves. The rings are new rod, and the cylinder was it was rusty. I did hone it out. Maybe it's just worn out, possibly, but I'm getting like zero pressure out of it, not even little fluctuations when I do the deadhead test. I would think even if this is worn out, I'd see the needle moving on the pressure gauge. So I'm wondering whether there's a problem with the reed valve here. So I'm going to do some real simple tests here on the workbench just to get a feel for what might be the problem here, the cylinder or this reed valve. All right, so I have the, here's the cylinder sleeve, here's the piston, the rings are in there. The end ring gap on the two rings should be 180 degrees apart, which they are. And I have the rod and the vise, and I'm just going to play with this here and see if I can feel the suction and the pressure. And I think you could hear that, but I'm getting a good shot of air that's flowing out around my hand. I'm getting suction. So even if this cylinder is worn and I'm not getting perfect sealing there, I'm probably getting that 40 psi that I've seen when it's running, even if that cylinder is kind of worn out and needs replaced, but I'm not getting 80. But when I deadheaded the, that's when it's running. But when I did the cranking test, you know, I'm not even getting any fluctuation of the needle. So I would think that I should see the needle jumping a little bit during the cranking test. So we're going to kind of do a similar thing. We're going to, the head just simply seals, there's an O-ring, and it clamps down against this sleeve. And what I'm going to do is put some silicone, and I'm going to repeat this. And I should have pressure coming out through this top reed valve against my hand here at this this ring here. And I really don't hear air moving, and I don't feel the same sort of pressure coming out. So for the suction to go in through the intake, the piston sucks air past this reed valve. But for the pressure to develop at the outlet of the head of this cylinder, this reed has to close tight so the air can be pushed out these holes against my hand here. And that's what I'm not feeling. I'm not feeling anything at all. So I'm thinking when the reed valve is in there, it's not sealing at all. And the air is just going back and forth around that reed valve. This seals around the outer edge of that. And when the piston goes down, it draws air in from this space right here, because this is the intake line there from the air box, and you can see that that is open into this space here. Now, what I found is a small chunk of aluminum that's taken out here, and I think my reed valve is not sealing against this, and that would probably allow air to seep by and probably cause what we're looking at on the gauge. I don't know how well you can see that defect, but it's a divot. This ski had a lot of salt water kind of in the inside of it. It sat for years, and that stuff will eat away at the aluminum. I don't know if that caused this or not, but I'm going to have to fill that void in. I'm not going to use JB Weld. I don't trust that. I think I'm going to have to weld this and resurface it. So that's what I'm going to try to do, and I'll let you know if it works. All right, so this is the repaired air compressor head. Here's the welded area that was had the divot in it. It should work now. So we're going to put it all back together and see what happens. Now I'm going to repeat the test after I've resurfaced the head. I have some silicone lube under that reed valve, and I'm going to put my hand here on the end and see if we can't get some pressure. I think you can hear that. It's definitely pumping now. At this point, that's the only problem that I can see with a highly likely cause of the low pressure. At least we didn't throw any other parts at it. If this head doesn't seal good, I might buy a used one. These aren't too expensive on eBay. Okay, so we have replaced the air pump head because we did not pass the deadheaded pressure test. We need 90 psi or higher, and it was taking a long time to just pump up to around 20 to 40, and it wouldn't hold pressure. So I got this replacement off of eBay, and it's in really good shape. So at this point, this has to be the problem. So we're going to just crank it a couple times and see what happens on the pressure gauge. All right, that's much better. And that means when we hook the pump up with the air pressure regulator in the circuit, we should get our 80 psi, and we're going to put the pressure gauge back into the test fitting here, and we'll be able to then we'll be able to run it and make sure we're getting a steady 80 psi and check the fuel pressure, and that should all be steady and at the correct pressures. All right, so we're going to start it up and check the air pressure. So there it is, perfectly 80 while we're running it idle. Alright, so our fuel pressure is fluctuating about where it should be. 107 is what we're looking for. Go ahead and rev it a little bit. So you can see it steadies out when we rev it a little bit. I think that's okay. I think it's just the regulator responding. But it looks good, sounds good, it's running smooth, and there you have it. As long as those pressures are correct, that's what you need to run the VI.